Hi students, welcome back. Today we are going to discuss the S block elements from classification of elements and periodicity in properties. Okay, let us start. S block elements. The elements of group 1, that is known as alkali metals, and group 2, that is known as alkaline earth metals. Group 1 alkali metals have outer electronic configuration, means that is NS1, and alkaline earth metals, that is group 2, which have NS2 outer electronic configuration. They have NS1 and NS2 outermost electronic configuration, so they belongs to S block elements. They are all reactive metals with low ionization enthalpy. S block elements are all reactive metals and they have low ionization enthalpy. They lose the outermost electrons readily to form 1 plus ions in the case of alkali metals. In the case of alkali metals, they have NS1 configuration. So, they lose 1 electron from its outermost orbit and then it readily to form 1 plus ion. Or in the case of alkaline earth metals, it readily give 2 electrons from the outermost orbit and to form 2 plus ions. The metallic character and reactivity increases as we go down the group. Metallic character and reactivity increases as we go down the group. Because of the high reactivity, they are never found pure in nature. Alkali metals have high reactivity, so they are never found pure in nature. The compounds of the S block elements, with the exception of those of lithium and beryllium, are predominantly ionic. The S block elements, the compound of the S block elements are predominantly ionic, in the exception case, that is lithium and beryllium. The P block elements comprises those belongs to the group 13 to 18, and these together with the S block elements are called the representative elements or main group elements. The P block means that is group 13 to 18 elements, that is known as P block elements, and these together with the S block elements, they are called representative elements or main group elements. Elements together with the P block elements are known as representative elements or main group elements. Okay, this is alkali metals, group 1. This is alkaline earth metals. These alkali metals and alkaline earth metals belong to S block elements. Alkali metals have NS1 electronic configuration and alkaline earth metals have NS2 electronic configuration in the outermost shell. So they have readily lost 1 electron to form 1 plus cation. Here alkaline earth metals lost readily 2 electrons to form 2 plus cation. Then group, this is 13th group, 13, 14, 15, 16, 17. This is noble gas. So, noble gas also belongs to P block elements. This S block together with this P block elements are known as, collectively known as, representative elements or main group elements. This 13th group means that is boron family, this is carbon family, this is nitrogen family, this is oxygen family, it is also known as chalcogens, and this is halogen family, and this is noble gas. 18th group means that is noble gas. The outermost electronic configuration varies from NS2 NP3 to NS2 NP6 in each period. In the case of the P block elements, its outermost electronic configuration, that is ns2np1 to ns2np6 in each period. At the end of each period is a noble gas element with a closed valency shell ns2np6. ns2np6 means that is noble gas elements configuration. All the orbitals in the valency shell of the noble gas are completely filled by electrons, and it is very difficult to alter the stable arrangement by the addition or removal of electrons. In the case of ns2np6, that is the electronic configuration of the noble gas, and it is very difficult to change the stable arrangement of this noble gas by the addition or removal of electrons, because their outermost shell are completely filled. So it is very difficult to alter the stable arrangement by the addition or removal of electrons. The noble gas thus exhibit very low chemical reactivity. Preceding the noble gas, two chemically important groups of nonmetals, they are the halogens, that is 17th group, and 16th group, that is oxen family or chalcogens. These two group elements have high negative electron gain enthalpy and readily add 1 or 2 electron respectively to attain the stable noble gas configuration. In the case of halogen family, its outermost shell containing ns2np5 electronic configuration. They need one more electron to attain the stable noble gas configuration. In the case of chalcogens, its outermost shell containing ns2np4. These two groups of elements have high negative electron gain enthalpy and readily add 1 electron in the case of halogen and 2 electrons in the case of chalcogens to attain stable noble gas configuration. The non-metallic character increases as we move from left to right across a period. Non-metallic character increases as we move from left to right across a period, and the metallic character increases as we go down the group. The P block elements together with the S block elements are known as representative elements or main group elements. Their outermost electronic configuration from ns2np1 to ns2np6. ns2np6 means that is the electronic configuration of a noble gas. They are completely filled and it is very difficult to change their stable arrangement by the addition of removal of electrons. Noble gas exhibit very low chemical reactivity. Preceding the noble gas, there are two chemically important groups of nonmetals. These are halogens and chalcogens. Halogens group 17 and chalcogens group 16. These two group of elements have high negative electron gain enthalpy and readily add 1 or 2 electrons respectively to attain stable noble gas electronic configuration. The non-metallic character increases as we move from left to right across a period, and metallic character increases as we go down the group. Okay. The D block elements, that is transition elements, these are the elements of group 3 to 12 in the center of the periodic table. Okay, the elements of group 3 to 12 in the center of the periodic table is known as D block elements. These are characterized by the filling of inner d orbitals by electrons and are therefore referred to as D block elements. In the case of D block elements, its outermost shell, that is S shell, but electron filling takes place in the inner d orbitals. Not in the outermost shell. Here the electron filling take place in the inner d orbital. So they are known as D block elements. Group 3 to group 12. These are known as D block elements. D block elements. They are also known as transition elements. These elements have general outer electronic configuration of n-1, d1 to 10, ns0 to 2. They are all metals. They mostly form colored ions, exhibit variable valency, that is oxidation state. But they are all metals. They mostly form colored ions, exhibit variable oxidation state or variable valency, paramagnetism, and often used as catalyst. These are the properties of D block elements. D block elements are all metals. They form colored ions, exhibit variable oxidation state or variable valency. They are paramagnetic in nature and often used as catalyst. However, zinc, cadmium and mercury, which have the electronic configuration n-1, d10, ns2, do not show the properties of the transition elements. So they are not considered as a transition element, but they are D block elements. Study clearly. Zinc, cadmium and mercury, which have the electronic configuration n-1, d10, ns2. So they are completely filled. Their outermost shell are completely filled. If their outermost shell are completely filled, they do not show the properties of the transition elements. If their outermost shell is incompletely filled, then only they show the properties of transition elements. So zinc, cadmium and mercury, these elements do not consider transition elements, but they are D block elements. In a way, transition metals form a bridge between the chemically active metals of S block elements and the less active elements of group 13 and 14, and thus take their familiar name transition. Transition elements, transition metals form a bridge between S block and P block. Transition elements lies in between S and P block. Transition metals form a bridge between the chemically active metals of S block and less active elements of group 13 and 14. So they are known as transition elements. D block elements, their name came from these factors, such as they form a bridge between the chemically active metals of S block elements and less active elements of 13 and 14, the group elements. Okay. Then next, the F block elements. F block elements is also known as inner transition elements. These the two rows of the elements at the bottom of the periodic table called lanthanoids and actinoids are characterized by the outer electronic configuration of n-2, F1 to 14, n-1, D0 to 1, ns2. Okay. These are known as lanthanoids and actinoids. The last electron added to each element is filled in the F orbital. So they are known as F block elements. Their electron filling takes place in the anti-penultimate shell. Anti-penultimate shell means outermost shell, then its inner shell means that is penultimate shell, then anti-penultimate shell, third shell. These two series of elements are hence called inner transition elements. F block elements, they are all metals. Within each series, the properties of these elements are quite similar. The chemistry of the early actinoids is more complicated than the corresponding lanthanoids. Chemistry of the actinoids is more complicated than the corresponding lanthanoids, that is due to the large number of oxidation state possible for these actinoid elements. Because the actinoid elements, large number of oxidation state possible. Okay, actinoid elements are radioactive elements. Many of the actinoid elements have been made only in nanogram quantities or even less by nuclear reactions, and their chemistry is not fully studied. The elements after uranium are called transuranium elements. The elements after uranium is called transuranium elements. The two rows of the elements at the bottom of the periodic table are known as lanthanoids. This is lanthanoids and this is actinoids. Cerium to lutetium and thorium to lawrencium. Cerium to lutetium, that is lanthanoids, and thorium to lawrencium, that is actinoids. In this case, the electron filling takes place in the f orbitals. So they are known as f block elements. Outermost electronic configuration n-2 f1 to 14, n-1 d0 to 1 ns2. Here the last electron added to the element is filled in f orbital. These two series of elements are called inner transition elements because they are known as f block elements. They are all metals. The chemistry of the actinoids is more complicated than the chemistry of the lanthanoids because a large number of oxidation states possible for the actinoids. Then the actinoid elements are radioactive. The elements after uranium are called transuranium elements. Okay guys, study up to here. The remaining topic we will take in the next class. Okay.